Hello everyone, welcome to LeetCode Daily Decode. This is the second video of the channel. Today we are going to solve this problem, maximum profit in job scheduling. The problem is marked as hard over here in LeetCode, and the main reason it is marked hard is because we are going to use two of the advanced topics, that is dynamic programming or memoization, as well as binary search in the problem. Most of the hard problems are marked as hard because we are required to improvise it in such a way that we need to use more than one technique to solve the problem, right? So whenever you see hard, you should get a uh, instinct. You should get an understanding that the problem will require not just one but maybe multiple uh, efficient approaches. So let's quickly understand the problem. We have n jobs where every job is scheduled to be done from start time I to end time I, and it will give a profit of I to do this job in this particular time. You are given the start time, end time, and profit arrays. Return the maximum profit you can take such that there are no two jobs in the subset with overlapping time range, right? If you choose a job that ends at X time, you will have to start another job that starts at time X. Let me quickly explain what this question is about. So as you can see, we have a start time array, end time array. Basically, we have four jobs to do, and each job require a start time and end time. And we'll have to think about the worker or the person who is doing these jobs. You'll have to think in that way so that he or she can maximize the profit while doing the work, all the work, including all the work, he or she can maximize the profit. So the question is pretty straightforward. There are two, in these questions, uh, when we are being asked to maximize or minimize, our first thought should go for a dynamic programming solution or a greedy solution, right? But you will have to figure out which one to choose, a dynamic one or a greedy one. uh, Most, like in this case, I can easily tell that it cannot be solved with greedy approach, because in greedy approach, mostly you will have to iterate over the array only once. But uh, for example, let's take this example. So if we let's say we take the first job, that is from 1 to 3, right, from start time 1 to end time 3. Then we have two options: either we can take 3 to 6 or either we can take 3 to 5. So we have got options over here, and there is no logical way to just quickly get ahead with this. Let's say if the profit 50 would have been here, right, and profit 10 would have been here, then uh, the entire solution, like the solution would be wrong if we just go ahead with the maximum profit between these two, right? If we are at 3, we have two choices: we can choose profit 40 and profit 70. If we go by greedy approach, we'll choose profit 70, we'll go ahead, right? But there might be some case where the profit is 100 over here, right? So a greedy approach is not something that we'll be going ahead with this, we'll be doing for this problem. uh, so the problem, as I told you, is about choices, right? So for the first job, you have two choices: either to include it or exclude it, right? If you are including it, your problem can be subdivided into a smaller problem. That is, like, I have included the first three, like first interval. Then my starting interval now changes to the third value, like 3. So my index of the next item, like, I can keep a track of the index of starting task, right? So initially the task starting from 0 index, and I have two choices: either to select this task at 0 or not. So if I am selecting, I'll then start my job from second index, because that is where the first job is ending, right? And that divides it into a sub problem starting from the second index. Same thing we'll be doing. So we have an idea that our recursive function will have only one parameter, that is the starting index. Now to make it more make it efficient, we'll do we'll sort this start time, end time, and profit uh, on the basis of start time, so that we can directly jump onto the next index based on our choices made for the previous index, right? So let us quickly get started with the solution for this. So this is how the solution looks like. um, we have created a list of tuple initially, and we have sorted it based on the start time. Then we have created a cache. We'll come back to this later. uh, we have defined a rec function, which is a recursive function that we are going to use for the job. And uh, so this naming is not correct. We can like give it a good name, and you should always try to make your naming in such a way that it is easily understandable. But yeah, just for the solution sake, I have written the name rec. um, yeah, so let me quickly explain what is going inside this rec. We have written our base case, that is, if the index starting index is equals to size, we'll return, like we have no elements, right? So we'll return 0 as the profit. This rec function is returning profit, right, starting from ith index. So the profit, if we are starting at ith index, what will be the maximum profit, the answer of the maximum profit, right? uh, then we are checking it in cache, which is what why we have created this cache. It is for memoization purpose. We are storing the values of previous answers inside this cache. uh, we have defined a start and end index, and we have given it value of 1 I plus 1 and size. Now what we are doing over here is basically like there are two cases, right? First case, in which we are choosing this value, the first index, and then we are uh, moving ahead with the next value, next available task that we can pick up, right? So to find the next available task, we'll have to iterate over the end time array, right? So if sorry start time array. So let's say if I am picking up the first job, my end time is 3. So any value which is greater than 3 in the start time array will be my next task. So like the next value which is greater than 3 or equal to 3 will be my next task, right? Should like ideally should be my next task. So my recursive function should get the index of that particular value. So like we'll have to iterate over the array that is taking an order of n time, and every time in the recursion we'll have to go and iterate in order of n. So to make it faster, we have implemented binary search over here, since our start time is already sorted, right? So we just need to find a start time which is greater than or equal to our end time, and we just need to return the index. So that is what we are doing over here, right? We are finding it using binary search, and then we are saving the answer. Like we are calling our recursive function first for the case where we are not selecting the given index, and second for the case we are selecting, where we are selecting, and we are calling the next uh, next possible task that we can pick up. So index of that particular uh, index starting from that particular task. So rec end plus interval of I 2, which is the profit of this particular task that we have selected, right? And we are saving it in cache I, and then we are returning cache of I. So in this way we have our recursive function, and at last we have just called this recursive function from our main function, that is the job scheduling. Let us quickly run and see. So it is giving right results for the test cases. Let's submit it. So yeah, the answer is correct for this case, and I hope you're able to understand the logic behind it. The main reason it was marked hard because we required two of the like advanced approaches, that is dynamic programming or caching, as well as binary search, to make it more efficient. If we would have searched like linearly, like one by one, it will give time limit exceeded, as you can see from my submissions. I have got time limit exceeded and just needed to change the approach to binary search approach, right? Even in the hints, if you are stuck at some places, you can see the hints. Uh, in hints also it is being shown that you can use binary search to uh, find the next index. So that is it from my side. Thank you guys for watching. I'll see you in the next video.